Assalamu alaikum y'all. I'm back with another video of computer science and artificial intelligence. So for this topic or for this video, we're going to be talking about the famous water jug problem or the water jug riddle, as we all know. So we're going to look what it is, and we're going to look at a simple example in which we're going to take two jugs. We're going to pour water from one jug to another jug to another jug and get the target volume of the water we want. So the thing is, it's easy, it's fun, and it's very useful. And now let's just jump right into the video. So now what really is water jug problem? The thing that comes in our mind is like there is water and there is a jug, and there might be some problem where we need to do something with the jug and water. Yes, that's the basic approach that we can learn from this algorithm by this. Basically, the easiest of this is let's just imagine there are two jugs, and we are going to use those two jugs to get a specific or the targeted amount of water. But the catch here is there are no labels, or you can say the measuring lines on a jug, or like the tubes which we use in labs, test tubes and some other tubes, beakers. The beakers have lines on them, even jugs have lines on them mentioning like it's 1 liter, 2 liter, 3 liter, 4 liter. But these jugs, they do not have those marker lines on them, and all we know about them is their total capacity. What's the total capacity of the jug X and what's the total capacity of jug Y? And we're gonna use that, and we're trying to get our targeted liters of jug or of water. So that's what basically it is. I've got a small example. It's a common example out there. We're gonna look at it. I drew it on my register and we'll go from there. So there are like multiple approaches for this, but the common one that we use is depth first search and breadth first search. For depth first search, I explained what it is in my previous video of and or tray. You can look at that as well if you want. Other than that, I'll tell you these are the two main ones. Plus we got two jugs. There's a jug X and there's a jug Y. We know both jugs have a complete capacity. We don't have markers on them. One jug has the total capacity of 4 liters and the other jug has the total capacity of 3 liters. So what we want is, we want 2 liters in jug number 1 or jug number X. But the catch here is the only actions we can perform is we can fill the jug completely or we can empty it completely. We can't keep half of the jugs. Why? Because we do not know the half jug, the half marks or the half water in the jug. Is it really 2 liters or is it really 3 liters or is it really 1 liter? So we're gonna play with the number we know, and that number is the complete capacity 4 and 3. So first of all, we're gonna completely fill the jug number Y with 3 liters of water because it's its capacity, and then we're gonna put it in jug number 4, jug number X, which has 4 liters. So now there's gonna be 3 liters in jug number X. We're gonna fill jug number Y again, and we're gonna pour it till the jug number X fills, which means only 1 liter would be added to jug number X because it already has 3 liters in it. What's gonna happen is we will be left with 2 liters in jug number Y because we added 1 liter in jug number X. So after that, we're gonna pour all the water out from jug number X and we'll be left with no water in jug number X but 2 liters in jug number Y. We've got one of our condition right. You can say an AND node that we got 2 liters. But is it in jug number X? Nope. So again, we're gonna transfer it. We're gonna pour from jug number Y to jug number X, and we're gonna get 2 liters in jug number X. Both conditions are satisfied, and we got our goal. So that's a pretty simple example, and you can say daily life implementation. Just like in the last video, I told you guys to look for some daily life implementation of DFS and or tree. You can say this is one of that as well, and it's a pretty interesting one. This right here is a small example in which we have 2 jugs with the 2 total number of capacity, but in real life we might have, you can say, 100 jugs, and we might need capacity of 50 jugs filled or 10 jugs filled or whatever, with a certain number of water or liters in them. So it's going to be pretty hectic for a human to do it. We're going to teach the machine from smaller levels. It's going to train itself. It's going to feed the results in it and work its way and give us that answers. It's also going to show us the alterations as well. And in the end, we can also get how much time did the machine took and the resources it took to complete that task. So guys, that pretty much concludes this video. This was the basic understanding in easy words, you can say, about what a water jug is, what fun architecture, fun algorithms we got in AI, and all these things mostly in AI we used from the daily life problems we had. We implemented them, and that's why AI it relates to us in daily life more than those conventional codes out there, and pretty much it's the future. So water jug, we saw it's a pretty good example how AI can solve a lot of problems for us. So that's it. Other than that, you guys can search more about it. It helps us in a lot of puzzles and other things as well. That's it for today, and I'll see you guys in the next one.